The Voyager 2 probe continues to amaze us. Now, more than 45 years after its launch, this incredible spacecraft has detected a mysterious movement in space, something that no one expected, and no one can fully explain. This discovery is a reminder that the era of the Voyager probes is far from over. While no one can say for certain how long these remarkable machines will continue to send data back to Earth, one thing is clear: even when they eventually go silent, they will continue to drift through space for millions of years, possibly still traveling somewhere in the cosmos long after humanity itself has vanished. Launched in 1977, Voyager 2 originally set out to explore the outer planets of our solar system. That mission was a resounding success. But today, the probe has moved far beyond those early objectives and is now venturing deep into the interstellar medium, the region of space between star systems. Despite being more than 4 decades old, Voyager 2 is still operational, still sending signals, and still rewriting our understanding of the universe. Each transmission reveals new data and raises more questions. Its latest finding, a stable and unexplained signal, has once again captured the attention of the scientific community and ignited speculation around the world. This new signal has been described as a gentle whisper in the cosmic darkness. It's coming from a place where there should be nothing but silence. The signal's frequency is around 3 kHz, and what makes it so puzzling is its consistency. For over 3 years, Voyager 2 has detected this steady signal in the interstellar medium, a place once believed to be an empty void. This raises immediate and profound questions. Is the source of the signal a natural phenomenon? Or could it be artificial, perhaps even technological in origin? When Voyager 2 was launched in the 1970s, no one imagined it would remain active beyond the 1980s. At the time, simply reaching the outer planets was considered a huge success. Yet here we are, decades later, still receiving data from a probe more than 20 billion kilometers away. Voyager 2 continues to dive deeper into interstellar space with each passing day. Over the years, engineers have had to shut down more and more of the spacecraft systems to conserve its dwindling power supply. Despite these limitations, NASA is doing everything possible to keep both Voyager 1 and Voyager 2 operational for as long as possible. The data collected by Voyager 2 has already transformed our understanding of the interstellar medium. Long ago, scientists assumed that beyond the heliosphere, the protective bubble surrounding our solar system, there would be nothing but sparse particles, faint radiation, and an overwhelming emptiness. But Voyager's data shattered those assumptions. Even with many of its instruments shut down, the probe still collects real, valuable measurements from this vast, mysterious region. One of the key scientific goals has been to measure the particle density in the interstellar medium. Estimates had placed it at somewhere between 0.1 to 10 particles per cubic centimeter, making it one of the most dilute forms of matter in the universe. However, once Voyager 2 entered interstellar space, it recorded a particle density that was nearly 40 times higher than expected. This was a revelation. A denser medium could help stabilize and carry signals more effectively than previously assumed. That might explain how a 3 kHz signal could remain so constant over time and distance. Still, the mystery remains. Frequencies like this don't simply appear out of nowhere. They are caused by some kind of force or phenomenon. In this case, some researchers believe the frequency might be related to plasma waves generated by the movement of electrons in interstellar space. Plasma, composed primarily of ionized hydrogen and helium, is the main ingredient of the interstellar medium. It is the dominant state of matter in the universe and is known for its ability to conduct electricity and magnetic fields. But what makes this specific signal so unusual is its stability. It doesn't fluctuate the way natural plasma waves typically do. To help visualize the anomaly, imagine the interstellar plasma as a vast ocean of particles. Now picture a golden arrow slicing straight through that ocean, maintaining its speed and direction with almost no resistance. That's what this signal seems to be doing, cutting through the thin water of interstellar space with remarkable precision. The fact that the signal remains stable across such a diverse and turbulent environment suggests it might have a powerful and consistent source. Yet, no known natural force in the interstellar medium can account for this. Another layer of the mystery lies in the nature of the plasma itself. It's not a uniform substance. Rather, It's a chaotic mixture of hot ionized clouds, cooler neutral zones, and constantly shifting magnetic fields. Signals traveling through this medium would normally experience distortion or loss. But this 3 kHz signal has persisted undisturbed. Whatever its origin, it has the power to cut through these irregularities and maintain its integrity. This opens up the tantalizing possibility, though purely speculative, that the signal could be artificial in nature. If it were a beacon or a transmission from an intelligent source, it would need to be powerful, consistent, and directed. At this point, there's no evidence to confirm such an origin, but the idea cannot be dismissed outright. Scientists continue to investigate the signal and hope to eventually trace it to a known phenomenon, or perhaps to something entirely new. Throughout its journey, Voyager 2 has faced numerous challenges. In 2023, a mishap caused the probe to lose contact with Earth after an incorrect command turned its antenna just 2 degrees away from Earth. At a distance of nearly 20 billion kilometers, even such a small misalignment meant total radio silence. Engineers at NASA worked for weeks using the Deep Space Network antenna in Canberra, Australia, to re-establish communication. Every command sent to Voyager 2 takes nearly 18 hours to reach it, and another 18 hours for a response to return. Eventually, the problem was corrected, and the probe resumed its mission. Then in 2024, new problems emerged. Cryptic and unclear data sets were received, suggesting a possible malfunction in the data transmission systems. Again, NASA engineers worked tirelessly to understand and fix the problem. These malfunctions are becoming more common as the probe's power supply diminishes year by year. Voyager 2 runs on radioisotope thermoelectric generators, which lose about 4 watts of power annually. Eventually, the probe will no longer be able to support even its most basic functions. The engineers liken the situation to maintaining 2 40-year-old computers built with simple technology by today's standards, but still capable of processing and transmitting complex data from deep space. Their simplicity, in fact, has helped the team diagnose and resolve many of the issues, even from billions of kilometers away. Despite the obstacles, the data from Voyager 2 continues to surprise scientists. Every day, the spacecraft sends new measurements that provide insights into a region of space no other human-made object has ever explored. This data has revealed alternating regions with fluctuating particle densities, variations in radiation, and unexpected magnetic interactions. Over the years, Voyager's instruments have helped to map out these features, building a complex and dynamic picture of the interstellar medium. What we now understand is that interstellar space is not a static void, but a living environment full of motion, interaction, and energy. The plasma in this medium plays a vital role in balancing the forces of the universe. It influences everything from star formation and supernova explosions to the flow of cosmic rays and the dynamics of galaxy clusters. Voyager's ongoing mission is a testament to human curiosity and ingenuity. These probes were never meant to last this long. And yet, they continue to serve as our eyes and ears in the furthest reaches of space. While they will never return home, and while we may one day lose contact with them forever, their journey will go on. Long after their radio signals fade, the Voyagers will still be out there, silent witnesses to the vastness of the cosmos. As we await further data from Voyager 2 and continue to analyze the mysterious 3 kHz signal, one thing is certain: space still holds many secrets, and we've only just begun to scratch the surface. Stay curious, stay inspired, and stay with Space Lab. Your journey through the stars continues here.